we want to talk about hybridization. Hybridization. Right, we've talked about hybridization before, but we talked about sp3 hybridization. If you want to know more about sp3 hybridization, you have got to go to my other video. But at the moment, what we want to talk about is sp2 hybridization. And I hope I'm going to be able to do this very quickly. Right, what does it mean? We have to start on the electronic configuration of carbon. And we have got to think of electronic configuration of carbon, but start at it at the ground state of hydrogen of carbon in its ground state. So this is the hybridization of carbon, right, in its ground state. And what happens now is that, remember that this is your 1s orbital, and this is your 2s orbital, and this is your 2p orbitals. Right, so what is going to happen is that we are going to have promotion of an electron, and the electron is going to be promoted. This electron will be promoted to this orbital, so this is going to be your promotion. So what is going to happen is that you are going to have this electron jump to a higher energy level, and what we will have is this. So now we have got one electron in there, one electron in each of the p orbitals. So this is obviously promotion, but what happens is that those electrons are going to be hybridized, which means that they're going to have the same energy level. As you can see, this has got a lower energy level than these three. So what is going to happen is that when hybridization happens, this is what is going to happen, right? But only one of the p orbitals is going to be left without being hybridized. So what is going to happen is that we'll still have two electrons in the 1s orbital, and then in this s orbital we have one, and in this s orbital we have one. In this p, in these two orbitals we're still going to have one, but now they are at the same energy level, which means that these orbitals have been hybridized. They've been hybridized, and then we have this one electron that is not hybridized, that is in there. So notice something: we've got this s orbital, and we've got one electron in the s orbital and two electrons in the p orbital, and that's the reason why this will be 1s1, and I mean 2s1, and this will be 2p 2 electrons. So obviously, because there are 2p2 electrons, which means that this is the reason why this is called sp2 hybridization. Now, what does this show? This shows that we have got three electron directions. And since we've got three electron directions, what it actually means is that we have got this shape, which is a trigonal planar. We've got a trigonal planar shape, and that means that the angle that is between the electrons is going to be 120 degrees. That's the angle. So now, how do we show this? I'm going to increase the page. Right. So how do we show this? Therefore, we can show this electron configuration, this distribution, or this sp2 hybridization in actually ethene, right? Which is C2 H4, right? And what happens is that like I said, we've got three electron directions. So we've got three electron directions. So this is the electron direction, but we have another carbon that comes here with 3 electron directions. And obviously, like we said, remember that we have got our orbitals that are going to look like this, right? Orbitals that are going to look like this, right? And our orbitals will look like this. And remember, we have got electrons in those orbitals, right? We've got these electrons that are going to be in those orbitals. So we've got electron there, electron here, an electron there, electron there, electron there, and the electron in there. So what actually happens, remember that we still have this electron that we were talking about here, that is the electron that is not hybridized. So where does it go? Well, that electron is going to come out of the page. So that electron is going to, that orbital will come out of the page like this, and right, like this, it will come out of the page, like so. But what is going to happen, remember still we have got electrons, an electron in there, we still have an electron in there, but these electrons are going to merge, they're going to come together, right? When these electrons come together, they are going to form, this is what is going to happen, and this is what happens. So the electrons have merged. So this is what we end up with, and right, this is actually going to form a pi bond, but these other bonds are actually, the other bonds that are in there are going to form a sigma bond. They will form a sigma bond. So we have a sigma bond that is actually there. So if this what happens now, because we have only shown the atoms of carbon, we have not shown the hydrogens, then this is actually what is called an atomic orbital. So how does it look like then if it is when we have got the hydrogen coming in, or the hydrogen bonded onto that? This is still what we are going to have. So we've got a carbon, and this is our orbital, the pi bond that is there, and then we are going to have our carbon here, right, that is there. And what is going to happen, remember that we have got these electrons that are here, right? They will form right, so we have got this that looks like this, and then we have our hydrogen here, hydrogen there with its nucleus, hydrogen, it's bonded, remember that they are together, and I'm doing this to a little bit quickly, right, so that we don't waste a lot of time. And this is then becomes an these are your hydrogen. So because now we've got hydrogens, then this becomes your molecular orbital. This becomes a molecular orbital. Now, right, so remember that the angle here is going to be 120 degrees because we've got 3 electron directions, and therefore we have got a trigonal planar. We've got a trigonal planar. So this actually has helped us to understand why we have got a trigonal planar and a tetrahedral in the sp3 hybrid. In the sp3 hybridization, we've got a trigonal planar, and the sp2 hybridization. The sp3 hybridization, sorry, let's do this again. sp3 hybridization, we've got the tetrahedral shape, and the sp2 hybridization, we've got the trigonal planar, and that is important for us to know, right? If you've got any questions, you can ask me You can ask me in the comment sections so that you understand the hybridization, the sp2 hybridization and the sp3 hybridization. We are going to go into the next video. We are going to talk about sp hybridization. Okay, so see you in the next video. Bye.